USB, one acronym that even a lot of non techie people know. They might know that they need it to power their phone, charge their kid's favorite toy, or maybe get their electric toothbrush up and running. But what they might not know is that the USB specification has gone through a huge evolution since its inception in the late 1990s. Now, USB 3.2 with 10 gigabits per second is commonplace. But you knew that, right? Of course you did. But maybe you didn't know that there's an easy way to quickly build USB 10 gig applications. That's right, with Infineon's EZ-USB FX10. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Chou from Infineon and I explore the challenges of USB design and how Infineon is furthering innovation with its EZ-USB FX10 solutions. We also investigate the high bandwidth data subsystem, the high bandwidth data interface, and the robust security features included in this solution. And before we get started, don't forget to click that link. There you can find even more information about this topic from Infineon. Hi, Jimmy. Thank you so much for joining me.
Hi, Amelia.
Okay, so Jimmy, we're talking about next-gen general-purpose USB peripheral controllers today. But before we get started, what all will we be covering?
So today we're going to cover the market trend and the issue the industry facing, and how Infineon addressed the problem with our latest product line. Also, I'm going to cover the application and the leveraging the latest USB speed, and also cover the development tools and some successful story from customers.
So, Jimmy, looking at the future of USB, what do you see are the biggest challenges we will be facing?
So after the USB 3, the industry facing the three main issues. Number one is there's limited building blocks for the higher speed, like a 10 gigabit introduced in USB 3.1. If you want to design the USB application with a 10 gig or higher speed, you pretty much limited to just FPGA solution. You to develop the whole protocol layers and all the IP that necessary to get the USB working. Another problem is the USB cable length getting shorter when speed going higher. For certain applications such as the machine vision camera, that you need at least minimum of 3 meter cable. So that also limit the speed going higher in such application. And the last will be the complexity that they're going higher with the higher speed is to support, and in general USB taking care of the backward compatibility, so that they move into higher speed, meaning that you also need to take care of the legacy of the USB speed. That will make design of the newest USB spec more complex, so that you need to spend more development time in terms of software interoperability testing. So this is going to be a problem for a lot of developers advanced in the USB speed.
Okay, so let's talk first about the trends in this area. We've seen a big expansion within the USB market since its inception of USB 1.0, right?
Yes, so this go way back to 1996 when USB 1 was first introduced to replace all the old connectors behind the PC. Back then you see that the PS2 parallel port and serial port, so Intel introduced USB to replace all those connections in the back. But the USB doesn't really grow until the USB 2 was introduced, which increased the speed by 40 times higher than the USB 1. So that gives enough bandwidth for many, many applications, such as the mass storage, that the flash drive you use, or external DVD-ROM drive, or Wi-Fi adapter. And so the growth in the number of applications exponentially since the USB 2 was introduced. So it continued until the 2008 when USB 3 was introduced. That gave another 10x of performance. And so that keep going. However, it starts slowing down since the 2013 when USB 3.1 speed of 10 gig was introduced. And then it doesn't really go any better when the USB advanced to the 20 gig with two LAN support in the USB Type C in 2017. And the USB just continued to go advance in their spec by combining Thunderbolt 4 into USB 4 in 2019. That increased the speed to 40 gigabit per second in total. And in 2022, that the USB 4 advanced to USB 4 version 2 with the Thunderbolt 5 support. Now, this be the time they introduced this USB 3 Gen T concept, which tunnel the USB data up to 120 gigabit per second of speed.
Okay, so tell us about USB 10 gigabits. All USB C ports use this connection, right?
Most likely, you can see 10 gig support in the USB-C port. There are probably a few that the really lower end computer only support 5 gig in their Type-C port. Most of them actually supporting the 10 gig. So 99% of C port supported, and even including some of the Type A port also support 10 gig. And however, you probably only see one of the application that actually using the USB 10 gig interface. Then Infineon they introduced EZ-USB FX10 general purpose controller for the USB 10 gig device in late 2023. And now that the allowed existing customer of FX3 can upgrade the speed to 10 gig and also the new bandwidth support that we can enable many new applications. And this is the product have been anticipated for more than 5 years. Now that with FX10, the number of applications gonna grow exponentially in the next decade.
Okay, so how is Infineon supporting USB 10 gig?
So FX10 is the first silicon that we introduced to the industry. The next generation of the silicon of our industry gold standard FX3, which has been used in many USB 3.0 application. We improved the interface to USB 10 gigabit with a new LVDS interface. The total bandwidth can support with FX10 is the 8.8 gigabit versus the 3.2 from FX3. So that's 275% of the increase from FX3. So that opened up the application to many imaging and video applications such as machine vision cameras and video frame grabbers. Also, many emerging applications such as the mixed reality headset can also benefit from this higher bandwidth. Right. We also see that the 3D scanners that used to be very slow in scanning speed with the USB 3.0, now with almost 3x of performance, much better in terms of the user experience. Also, in a lot of test and measurement, the application that definitely can leverage high bandwidth, allow more the data to be acquired, such as the spectrum analyzer or oscilloscope or large analyzer.
Okay, so talk to me about some of those applications you mentioned. What about a machine vision camera? How would this solution support this kind of application?
FX3 has been used in machine vision camera since the USB 3 Vision standard was introduced back in 2013. So this USB interface has greatly improved usability in terms of machine vision camera. However, the resolution and frame rate keep increasing the quality, higher bandwidth. Now can actually improve the in terms of the resolution, the capability, and the frame rate. So what FX10 is doing inside the machine vision camera is interfacing between the imaging source and the connect the USB host from the PC. So it handle all the USB enumeration and all the protocol, the communication necessary for the USB 3 Vision. And it got this feature called coherent trailer insertion, which greatly reduced the design effort into the APGA, that the setting between the image sensor and the FX10. And it transfer data as fast as the 10 gigabit from the CMOS sensor to the PC. And however, to support the different type of image sensor, which use different standard in terms of the interface. So FX10 in general would require APGA to sit between the image sensor and the FX10 to process image data to buffer into the FX10 using the LVDS or LVCMOS, the interface. So of course the image sensor will take all the raw image data and the stream to the FPGA and then using FX10 to transfer all those data back to PC.
Okay, so can we dig a little deeper into this solution? What kind of features are we talking about?
So the main feature in FX10 include this new USB 3.2 Gen 2 device port that capable to do 10 gig and 5 gig and the legacy USB to 480 megabits of speed. And FX10 USB 3 port also can support this USB-C plug orientation detection and correction. So the design of the USB-C port much easier. We also improve our CPU platform to integrate dual core CPU and with the 150 megahertz Cortex M4 and also the 100 megahertz Cortex M0. And this is the first time we also integrated flash memory in the chip, the 512 kilobyte of the flash memory to store your application firmware. So there are 128 kilobyte of SRAM for program memory, additional 1 megabyte of SRAM memory for buffering the data between the FPGA and the USB. We still have the legacy LVDS mode to support 32-bit data bus, much faster speed compared to FX3. We also introduced LVDS mode for higher speed support for up to 16 lane of the receiving data at 1.25 gigabit per second for each lane. Split into two ports instead of the one port from FX3, so that gives you more flexibility in terms of connecting to your data source. FX10 also include a lot more peripheral I/O ports compared to FX3. So there are two quad-SPI interface that can also be combined into one octo-SPI interface for connecting to external memory. There are 7 serial communication blocks we call SCB, which can be programmed to support I2C, SPI, CAN, or even UART protocol. There is one additional USB full-speed device port built into the FX10, which can be used for the debugging purpose. You don't need to put the UART to USB serial bridge externally to take the log data back to your PC. For the audio support, we now include 2 pair of the I2S and PDN to PCM port, and there are many GPL included in the FX10. We also include this cryptography accelerator in the FX10, so you can do encryption, decryption for your data. Lastly, we kept the package same as FX3 in 10 by 10 BGA package with 169 ball and 0.75 ball pitch.
Excellent. Now, can you also talk about the interface of the EX-USB FX10 a bit as well?
USB 3.2 Gen 2 PHY that the design in the FX10 is done everything in-house from scratch. That include 2 independent lanes that you can select without using the external mux. It support 10 gigabit of speed for each lane. The best of all for this can support up to 28 dB insertion loss. So that capability allows higher speed and longer USB passive cable support. We also keep the transmitter and the receiver very flexible for the application to program them on the fly. Upon each connection that you can optimize both transmitter and the receiver by adjusting the configuration to make the connection optimized. Then how do you know that the signal quality coming to your application is good? There's a feature called iMonitor, which allow you to get the data from receiver to see the eye diagram of your connection. In this picture on the upper right, we see the eye diagram generated from the FX10. So this is the connection in 10 gig speed over 5 meter passive USB cable. So you can see comparing to the iMask, there's still a lot of margin. And you can see how great this USB 5 performed in terms of the high speed in the longer cable. They support legacy USB 2 speed as well as all the 32 physical endpoint available from the spec. So you don't really need external mux to support the Type-C lane switching. And you also don't need the external CC logic to detect which side is connected to your device. To make a PCB layout simpler, differential signal that can also change polarity. So that will make the routing through PCB much simpler. The FX10 doesn't support the power delivery. By the pull down the both CC line for the Type-C connection, you can get up to 3 amp of power over 5 volt. That's total of 15 watt of power for USB device.
Okay, so what about the high bandwidth data subsystem? Can we also chat about that as well?
Sure, FX10 is an interface controller, which means that you gotta have data from one side sending to the USB side. It's actually quite challenging when speed go higher and how to interface to your data sink or source for your application. The old FX3 support 32-bit VCMOS interface, which is not enough when speed going higher. So we try to design this interface as flexible as possible so that any application can leverage the FX10 for their higher bandwidth the application. So what we did is we have the DMA fabric to optimize the data throughput between your interface to APGA and the USB PHY up to 10 gigabit per second with the 1 megabyte of data buffering that prevent any the data drop when there is some hiccup from the USB host, right? The interface to the APGA that we call high bandwidth data interface can be configured to be either LVDS or LVCMOS based on your need. So that two port of the interface can be combined into one or separate as two narrow links. It allows you to give the maximum the performance for this data subsystem.
Okay, so we should also talk about the high bandwidth data interface as well.
First of all, in LVDS mode, we only provide one direction of the traffic, which is the receiver only, because the data coming from the external source to the USB host or to the PC. So the data acquisition application require high bandwidth, represent probably 99% of the application out there. That's why we only put the receiver into LVDS mode to optimize that usage. Each port consists of 8 data lanes and 1 clock lane and 1 control lane for this LVDS mode. 2 ports can be configured independently or together. We can support many different configurations in terms of data lane. I can use 1 lane, 2 lane, 4 lane, 8 lanes, or even up to 16 lanes. So with the 1.25 gigabit maximum bandwidth for each lane, so total maximum performance you can get with 6 lanes. So it really depends on your design. So this interface will make it the selection of APGA much easier. But with only unidirectional data, we still need to communicate to APGA. So you can use the control signal provided with LVCMOS connection. So you can then let APGA to know if the link is ready or if the transfer is entering flow control. You can also use the I2C or a SPI interface to communicate to APGA. To support low power design, that there are 3 power states supported in LVDS mode. So you can always make the FX10 enter in low power mode to save power when not use it. And we also support the Gbps programmable state machine to make the data coming into FX10 more flexible in terms of your data flow. From the legacy connection, we have this LVCMOS mode that's the same as FX10. Difference from before is now you have flexibility using this 2 port. So one usage can be having 1 port configured as LVDS mode to support 10 gig of data from the APGA to FX10 and using the other port to be configured as LVCMOS with 16 bit of data, you can get half of the total bandwidth in the opposite direction. So this allows the simultaneous data transfer between your APGA and FX10 at the 10 gig of receiving side and the 2.5 gig at the transmitting side. If you want the maximum performance, also consider the bidirectional transfer. Then you can combine 2 ports into 1, leveraging 32-bit data in both directions. However, the clock for the data in the receiving side can support higher clock rate with 160 megahertz. And DDR, it can get total 32-bit up to 10 gigabit of performance. But on the transmitter clock, we can only support the half of the speed. So 80 megahertz DDR will give you maximum performance of 5.12 gigabit per second. So if you're familiar with FX3, same GPF interface is also supported in FX10. So this will help you to make your data easily configure as either the FIFO slave or other configuration you needed.
So, Jimmy, also walk me through the CPU and security aspects of this solution.
Okay, so we talk about this platform. The security is getting higher and higher, especially in the EU. How to protect your device being hacked with the unknown firmware or being steal from the hacker. With FX10 using Cortex M0 CPU to handle this secure boot operation. So in this picture here, the sequence that when powering up the FX10, the right-hand side showing a simpler version of the secure boot sequence. Any firmware that detected not valid signature, the CPU will simply just stop the operation. So this will prevent any unknown firmware program to your application, and also can help further secure your device.
Okay, so does Infineon offer an evaluation platform for the EZ-USB FX10?
Yes, to simplify the development cycle, in particular, there are so many different APJ you can choose from. We introduced the FX10 DVK with FMC connector. The FMC stands for APJ Main Card. This is the standard used in the APJ development platform. You can find the FMC socket. You can simply just drop in the FX10 DVK into those socket, then you can start your APJ development. The DVK also can be powered from the USB connection, so you can have the standalone operation without additional power source. There's actually one Type-C on the bottom side of the PCB, so that port can be used for connecting to your PC host as the virtual COM port, so you can have your debug message to output that port for your debugging purpose. You can also program that full speed port for other usage if you want. It's just completely independent to that USB 10 gig port on the top. We also provide the header for SWD and JTAG connection. You can also use it with the external programmer for your firmware development and debugging. So there is an optional GPU accessory port we offer that will give you very easy connection to the bottom side of the 40-pin connector to FX10 DVK. So that bring out all the peripheral I/O port into this dollar card. So there are headers you can connect to other peripheral. And also we include the USB programmer into this card so that you don't need to use other USB programmer firmware downloading and debugging. So that's the hardware part of the development tools. We also provide the software development platform to make your design of the firmware much easier. So because the software is really very crucial for any USB development. So with the new CPU platform, now we support the Models Toolbox, which is used in many Infineon microcontroller devices. All right, this platform can support all the major OS such as Windows, Linux, and Mac OS. And in the Model Toolbox, you can find the support in FX10 DVK BSP in there so that you can initiate project based on the FX10 DVK very easy. And if you have any need for the support, there are a very big developer community and the people share knowledge and blogs and many documentation on that the community. So you answer quickly that using the Model Toolbox. So to make it even easier for the firmware development, we are going to introduce this EZ-USB code builder. So this will jumpstart your firmware development by simply click and select the configuration you need for your application. You want to select a USB interface to be UVC or USB 3 Vision or HID, right? And you can also pick the APJ interface, either to be LVCMOS, LVDS. This tool then compile and build this firmware image that you can actually program to FX10 directly and start to get all the functions start working. So you can also export the end result back into the Model Toolbox to do your fine-tune or customization for your design.
Excellent. Now, Jimmy, reference designs are always useful to have. So, does Infineon offer any for this solution?
Yes. Since most of applications are in data acquisition or into imaging the transfer, we make this MIPI to USB solution kit. So this will allow up to 4 MIPI CSI-based camera to be connected to this kit. The APJ on the board, so the APJ we select this kit is the FNX TI-180, which is capable to have the MIPI connection to your camera. So the total bandwidth for this kit to support is up to 8.6 gigabit performance. So you can split into the 4 camera or using one dedicated camera for that bandwidth. So that bandwidth translates to the format. The image is 4K. We use YUV422 as our sample firmware, and so that gives you up to 65 frames per second of the speed. The firmware support for this kit include not only the UVC, the USB video class, but also the USB 3 vision for the machine vision. So that will help you to design this kind of application very easily. And there is another QSC excavation connector on the kit. If you need the additional feature you cannot find on this kit, you can always build a dollar card with that QSC connection to expand your feature of your device. We also make this Sony camera module with IMX715, the sensor. This can help you to quickly evaluate machine vision camera application.
Okay, so do you have any examples of this solution being used in real world designs?
Okay, that's a great question. So I want to share this success story from one of our customer, Aronia from Germany. So they're making real-time spectrum analyzer, which is very successful in this industry. That one of the usage for this analyzer is protection. It's actually been used in the G20 summit a couple of years ago in Bali. So in the old design, they use our EZ-USB FX3. However, the bandwidth requirement is very high, so they have to include two FX3 and the two Type-C connections just for the data bandwidth for the analyzer. And because of the complexity of design, it require higher power, so they actually need a dedicated Type-C port for power supply to support the PD to get in power from the charger. Now you see that with the FX10, that you see the picture in the bottom. With FX10, the whole design eliminated all three Type-C port and changed that, replaced that with just one USB Type-C port, which supply even higher bandwidth and with the power that is enough for the whole design of the 15 watt of power.
Fantastic. Now, Jimmy, can you walk us through the different specifications within the EZ USB 3.2 peripheral controllers as well?
Sure. So with this new controller family, not only the FX10, but also including FX5, FX5N, and FX20. Now we have total of 60 USB 3.2 peripheral controller in our portfolio. So starting from the left, CX3 and FX3, those are our legacy. The product has been used in industry for over 10 years. And with the new family to the right, so with FX20, you can get up to 17.6 gigabit by using both lane of the Type-C connection. With the FX5, it is the USB 5 gig connection, but it still improved performance from 3.2 of FX3 to 3.7 because of the newer design into the high bandwidth data system. And with the two lane in Type-C connection that give you total 7.4 gigabit of the bandwidth for FX5N. We also call it the USB 3.2 Gen 1 by 2 connection. For FX5 and FX5N, since the data clock rate is at 5 gigahertz or 5 gigabit, so that make the cable LAN support to be up to 10 meter, which means that you can have this 10 gig connection using FX5N over this 10 meter USB passive cable. Definitely gonna give the application like machine vision camera more appealing to the industry. So for FX10 and FX20 that are running at the higher clock rate, the 10 gigabit, that still give you the 5 meter USB passive cable support, which is super fast for such a long distance. So all four products share the same feature in terms of the CPU, memory, everything, the packaging, and everything are in production now. So you can get the sample from your distributor or from Infineon.
Fantastic. So, Jimmy, what do you think are the biggest benefits of this portfolio?
Number one is definitely the performance, right? That's what people will need for their new application. For FX20, you get up to 600% from the FX3 at the improvement. With FX10, you get up to 300% of the performance improvement. The second benefit from this portfolio is we offer a very small package, 10 by 10, the BGA package. With the new product family, you can support the USB-C direct connection without additional high-speed MUX. Integrated flash, you further save from your total BOM cost. The third benefit is definitely saving time in your development. Lots of example in the firmware, the tool like CodeBuilder that they are to speed up your firmware development, and also the hardware tool that's for your quick development platform to be built. And so all these tools will simplify your design and make your product to market much quicker.
Fantastic. Now, what kind of applications do you see USB 3.2 being a good fit for?
The new higher bandwidth can be used in other applications such as scanner, test and measurement the application, and many the APG module for expansion or system on module. And of course, we want to see this new bandwidth will open up more possibility for emerging application such as the mixed reality headset or XR, MR, or AR. Also, to bridge from other interface into this high bandwidth USB, right? Converting from Ethernet or PCI Express to make this plug and play connectivity available for more people.
Fantastic. Okay, so what would you like my audience to take away from today's Chalk Talk?
All right, so the key takeaways from today's talk is number one, of course, the FX10, and that will give you the quickest way to build USB 10 gig application. That also apply to the new best-in-class USB 3.25 that can support the USB passive cable up to 5 meter for the 10 gig connection using FX10, or using FX20, you can get up to 20 gig of the data throughput in the 5 meter passive cable. We cover the variant in the family that from 5 gig to 20 gig that is supporting all different combination of the USB mode support. So this will allow the growth number of application in the industry for the next decade.
Excellent. Now, Jimmy, if my audience wants more information, what kind of supporting assets does Infineon offer here?
So from our website, you can find the product brief data sheet of each product. And we also have the white paper app note to cover the market, cover how to use the new product to create your creative design from the EZ-USB family. We also post all the podcasts we have done in the past. And you can also find the forum from developer community to see how people using our controller for their design. Of course, you can download the software tool for your next the USB design.
Fantastic. Well, Jimmy, I think that's all I have time for today. Thank you so much for joining me.
Okay, thank you, Amelia.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Infineon. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.